Okay, so this is notes for 6-1. So it says the cubic functions are degree 3 polynomials. So the highest exponent is 3. And it tells you the vertex form, which really isn't vertex form, but whatever, is that equation. Then it says the equation for the parent function is y equals x cubed. So you're supposed to graph it. The table all we really care about is those x values, because the cube gets big fast. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So negative 1 cubed is negative 1 times negative 1, which is positive 1 times another negative 1, so it's negative 1. And then negative 2 cubed is going to be the same as 2 cubed, except there's a negative. So that's the points that we really care about, and that's the only points we can really plot on our graph. So the right arm almost looks like it would be quadratic, and the left arm looks like it would be the negative half of the quadratic. So it looks like almost two quadratics split, two parabolas split, and one fell over. And so the arms reach all the way up to positive infinity, and this arm goes all the way down to negative infinity, so the range is all real numbers. And as I'm moving out, my x is going to negative infinity and positive infinity, so my domain is also all real numbers. And then these points we kind of talked about the other day. I could rotate this point negative 1, and it would be this point 1, 1. So that's a rotation of 180 degrees. So that's its symmetry. All these points along one arm can be rotated 180 degrees, and they'd be on that arm. So the parent function has intercepts at 0, 0 for the x and the y. So that's the parent function. I'm going to look at two examples of transformations. So the first one I multiplied by 3, so that's called a vertical stretch. My y values are getting further apart, so I'm multiplying each time by 3. And so I could make a table. So if I didn't move it left and right, up and down, if I just had a vertical stretch, I'm going to look at my original table. So 0 times 3 is still 0, negative 1 times 3 is negative 3, 1 times 3 is 3, 8 times 3 is 24, and then negative 8 times 3 is negative 24. So you can see the middle points, they only change by 3, but after that they're changing by 21, whereas the original, they only change by 7. 1 and 8, and negative 1 and negative 8, their change was only 7. But that change was being multiplied by 3. So now in the vertical stretch, they're changing by 21 units in between. So that's a stretch. And so, but I also have some other things going on, so I can't really use this table. Vertical stretch by 3. Then if I subtract it on the inside, that's making it go to the right. Right 2, up 4. So the first point I need to look at is my inflection point. The inflection point on the original is at 0, 0. If I move that to the right 2 and up 4, I'd be at 2, 4. And then I have a vertical stretch of 3, so the next point is going to be way over here. The domain is all real numbers, the range is all real numbers. So over here I have a negative, I have a 1/2, I have a 3, and I have a -1. So I have 4 transformations. I'll start making bullet points. The negative is going to make my graph flip over the x-axis. So all my y values, all the positive y values would be negative, and all the negative y values would now be positive. So that's the y-axis, but the y-axis is being flipped over the x-axis. It's a reflection. And the 1/2, if I'm multiplying by a number that's smaller than 1, all my y values are going to shrink. So we call that a compression. So I'm adding on the inside, I'm going to the left. And then if I'm subtracting on the outside, I'm going down. So again, I'm going to start at 0, 0. I'm going to go left and then down. So my inflection point is -3, -1. The inflection point on A was 2, 4. Then from there, it's upside down and it's going to be wider, so it's going to look something like this. I'm kind of lazy, so I don't really care about plotting any points except for my IP, my inflection point. Domain, the range. All real numbers. So then I'm looking at graphs. I'm trying to find the equation based on the graph. So you can see my inflection point here is at -3, 0. The inflection point there is at 0, 0. The inflection point here is at 3, 0. So I can see there's a shift of 3 in A and C. So there's a shift left 3 in A and a shift right 3 in C. Then up here it tells me there's a vertical stretch by 2. There is a compression by 1/2, and there is a compression by 1/3. So my equations, if I went left, it's x plus and then B did not shift left, right, up, or down. So it's just 1/2 x cubed. And then this one I went right, so it's x minus then on B, my inflection point's labeled for me. I need to find the coordinate 1, 3. And that next point is at 2, 10. So the difference in the y values is going to tell me my vertical stretch. There was a vertical stretch by 7. No, by 6. I'm sorry, by 6. Because the next point should have been 2, 4. And so from 4, it was stretched by 6. No, it's 7. it's the difference in the y values. So then my inflection point tells me that I went right 1 and up 3. So I have 3 transformations. Right 1, up 3, and VS by 7. So my equation, 7 times x minus 1 plus 3. So I put it in the calculator so we could make sure. I should see 1, 3, and 2, 10 in the table. And I do. And the last 3, create an equation based on the information. So the inflection point being at 3, 4 means I would have gone right 3 and up 4 from the origin. And there was a vertical compression by a factor of 3, which means I multiplied by 1/3. And the graph's reflected over the x-axis, so I multiplied by -1. So when I put those two together, I multiplied by -1/3. So to show I went right, I subtract. To show I go up, I add on the outside. So B is kind of like B from the graph, where I was kind of confused between the 6 and the 7. The difference in your y value tells you your vertical stretch. So the difference here from 0 to 6 is a stretch of 6. So I have y equals 6x cubed. Because the 0, 0 tells me there was not any left, right, up, and down action. It stayed at the origin. So the only thing that could have happened was a reflection, or a stretch, or a compression. And my y values got bigger, so it had to have been a stretch. So C says there was a reflection over the x-axis, a vertical stretch by 2, and it went left and it went down. So I'm going to say it went left, it went down. And the stretch I multiply by 2, the reflection is negative.